Hey guys, welcome back to another episode of the Real Hacker Hours podcast. This is basically where I just do the normal side work that I typically do, but just hit the record button before I do it. This time I'm going to be reversing Apache, or working on that. Apache being the web server. So, getting to it, let me pull up a terminal here. Okay, so we can see right now there really is no Apache process running, Apache being HTTPD. This right here, we're just listing all of the processes that have HTTPD in them. This one that you're seeing right here is just effectively the grep for that process. So what we're going to do is we're going to go ahead and run Apache. And cool, now we see that there are 4 additional Apache processes that have started. Now we see one that's running as root and 3 that are running as daemon. While I don't know right now, since I haven't looked at everything, I believe that this root run is kind of just manages the other processes, and these 3 are just for effectively actually handling and servicing various requests. So what I'm going to do right now is I'm going to, excuse me, I had a burp. I'm going to attach a GDB instance to all 3 of these processes. That way, what I can hopefully do is effectively follow through in a debugger roughly the process or the code path for what happens when Apache actually gets a packet, so I can get some introspection to how that works. Cool. Gonna attach to. Also, one other thing I'm going to do before I start doing it, we can see here that we can clearly send a request to Apache and get a response back. After we attach GDB to each of these 3 processes and have them all break, we should not be able to effectively send a request to Apache and have it return a response, since all of the worker processes that service that will have been paused and not able to run code at that particular moment. So let's do this. It's the first one. 2818. And this GDB command attach followed by the PID. This is just, it's attaching to a separate process. The PID is the process ID. So we have attached each of the worker processes. None of them are running. And when we send a wget command, we see that it's not returning response, meaning most likely that one of these 3 processes, or probably all 3 of them, are responsible for handling the requests. So we should be able to use one of these 3 instances in order to actually follow the code path. Now, I know yesterday, hang on a second. Okay, just like peeking around the source code and stuff and the binary, APR socket rev, I know that this is a function that is along the code path for when Apache gets a packet. I believe how I got that was just by just looking around the functions in the source code and the binary itself. I threw it in Ghidra. So we're going to take this. I'm just going to set a breakpoint in one of these worker processes. I'm not going to set it in all 3 because I think it'd be easier just to follow it with one. And we run it. It got a response queued, I believe, from the wget we just did. So that's what that's from. Where is... Cool. So let's run wget. Okay, just out of curiosity. So we see here that Apache has spawned an additional worker process. This one right here, 3044. It appears what happened is when we tried using wget, it ran the first one without triggering the breakpoint, and then the second one it ran actually appears to have triggered that breakpoint. What I believe happened is the first one went to the other worker process, and the second one went to the worker process that we actually set a breakpoint for. But yeah, cool. So this is a worker process that has hit the breakpoint for APR socket receive. I am just info frame. No, I'm dealing with so many debuggers, I forget commands for each one. Thanks, WinDebug. Getting back to the point. So we see here, this is the call stack that APR socket receive actually has, and here it is. Here I saved it. Now, one thing I'd be curious of. Okay, so we see here in REX, RSI, and R15 what looks like the request. Looking at the registers, it looks like they're the same memory address. And actually makes it with RSI since that's the second argument. What I'm going to go ahead and do for now is, for breakpoint, delete I'm going to not delete that breakpoint yet. I'm going to set a watch point for, yeah, this data right here. Because what I'm kind of curious of right now is like what the code that actually interprets the packet is. I know since Apache is open source, we have source code. However, that source code can be a bit like a textbook at times, and there can be a lot of functions that like appear to do something but don't actually have that functionality. So it can just help just to like see what actually happens when we run it. So we set the read breakpoint. Let's see. Okay, appears that we hit socket receive again. Socket receive. Okay, so that was interesting. It does not appear that the read breakpoint was ever hit. Possibly because, hang on a second. Continue. It could be because there was like multiple copies of the packet in memory and it just didn't use that one. Or, okay, let's take a look at how many different processes do we have now. 1, 2, 3, 4. I'm gonna attach a GDB instance to the new process that was created. Attach 3044. So this next wget, unless the new process was just started up, should trigger the breakpoint. It did. Good. That is what we expected to happen. BT. For some, I get the urge to type like not W, dot K or something, whatever the WinDebug command is for viewing the call stack. Process, Apache run process. I'm just going to take a second look through this call stack. AP process HTTP async connection. Okay, I'm gonna try. Wait a second. What is this? Isn't this looks like the read breakpoint was hit. Yeah, this isn't the APR socket receive. You can clearly see that. Hang on a second. Oh. 0. What was the R watch? Okay, this is a bit weird. Okay, I'm just going to clear off the second breakpoint. Delete 2. Okay, here we're at APR socket receive. View the code. Curious what I'm going to look for this function in the source code real quick. I'm looking for like the function declaration so I can just quickly look and see what it is. APR socket receive. Not it. It looks like some other function is being set to APR socket receive there. Requests. No. Not it. Okay, that's a bit weird. I'm not seeing a function declaration. Maybe I'm just missing it? I don't. Exports ap.c. Okay, I'm not seeing it. Hang on a sec. I'm going to take a slight detour. Let's go into the Apache source code again. Server. Requests. Request.c. I'm just going to take a quick, just stroll through here. Declare. Self-some link. Okay, cool. So, one thing I'm going to go head back here for. I'm just going to continue. Well, there isn't a PCT command for this, so I can't do that. Socket run. Let's see, what am I trying to find? I'm trying to find where Apache actually handles this data. I'm just going to try singing another R watch for here. If a breakpoint, delete 1. Let's see. Nope, does not get a hit. Okay, tried that a second time, did not work. Hang on a second. Okay, I'm back. What I tried doing was just running some grips for like process connection stuff, and I found this file under modules HTTP core that has some things like AP process HTTP connection and create request. And if we look over here, AP process HTTP connection, we see this. So let's just try take a second and like follow, since we have identified, oh hey, this function right here corresponds to this function, the call stack. Let's just like see what the code path is in the source code. So we see it runs async connection, which then runs AP read request. Okay. Is that in here? Let's see. No, that is not in here. AP read request. H looks like it's include HTTP protocol.h. Well, server protocol.c. Okay, cool. Let's look in there. Oh yeah, I saw that because I did this grep and we see right here. Looks like, yeah, it's declared in server protocol.c. Okay, cool. So this looks like it does a lot. I think this, I believe this is the entirety of the function right here. Okay, cool. Gonna throw that here. Okay, cool. So let's just quickly browse through this function. Probably won't be able to understand a lot of it at just first glance. Creates a pool. I'm not sure what that is. Tag. Not sure what that is. Allocates size of a request. Create requests. Okay, looks like this is just setting up the data structure that it uses to store a request. Also, another thing to note is that this returns what looks like a custom structure that was referred to as a request rec, so I probably want to look at what that type is right after this. Read request line. Okay, so if this does not work, then all of this, we have to... I wonder, how many times is this function called? Is there like while loop? Timeout. Okay, cool. So at first glance, what it looks like this function is largely responsible for scanning in the request into memory and starting to set up actually setting up whatever the data structure in memory for a request is. I'm going to take a second and let's see if we can't find where this is. I'm guessing it's in protocol.c. Or probably protocol, whatever header file these functions are declared in. Gonna run a grep for it. Grep ap.d. http.h. Okay, cool. Let's take a look at that file. Struct. Okay, here's the actual struct itself. So has a ton of metadata. So I'm not sure where to pull this, but it stores it. The connection used to the server. Oh, the virtual host, the connection. Some request associated with this request in particular. Okay, that's under the same category. So this is a pointer to the first line of the request itself. So the actual data of the request is what it looks like. Looks like more metadata here. Method number, okay. And the rest of it, from just glancing, it looks like it's just header not header metadata. Metadata about the request itself. Okay, cool. So we have a rough idea. So roughly what happened, how Apache will take a request and actually scan it into memory, runs AP process run connection, which calls this. The reason now, I think the reason why it doesn't just outright call process HTTP connection instead it calls run process connection is it's probably, oh, definitely. Apache can probably handle different other protocols, definitely HTTP and HTTPS. So it adds on this additional function so it can handle that roughly. And yeah, okay, getting back to the original. Three sentence TLDR of like what we've seen. Well, effectively run these functions to scan into memory and populate it into this particular type of struct that we see here using these functions. Okay, that seems like a really gross oversimplification when I state it like that. But yeah. Okay, cool. That being said, what does it do after it scans? And I think that might be a little bit interesting to look at. So let's go back to, I believe, AP process. AP. Okay, so this is the AP process HTTP async connection function, which is called as a part of this. So we see here what it looks like. Calls AP read request. This is a check to see, oh, hey, was it actually able to read it in? It was. Run this code here, which I'm assuming is the additional processing of that packet. This right here is probably just some error out for like, oh, hey, didn't work. Yeah, it even says so here in the comment. AP read request failed. Cool. Does a check here, oh, hey, if the status is okay, cool. If extended status AP set, I'm not sure what that is. Update child status. AP process async request. That looks interesting. I'm going to take a look at this one. Where does R come from? Request. Oh, R is the output of AP read request, which is the request itself. So we saw in this G. Can I? I'm going to set a breakpoint for that function. Okay, looks like this read breakpoint is just getting hit. Yeah, one thing you might see is if you leave read breakpoints around, that memory might be freed and then subsequently used in different algorithms that have nothing to do with the algorithms that you are looking to look at. So I think that's what you were seeing right there. We did a wget and we hit AP process async request. Let's take a look. Okay, the call stack looks roughly like what you would expect it to see. I say roughly because I don't have the exact call stack memorized, but I see it's called from process HTTP async connection, which is called from process HTTP connection run process connection. So that's what I was kind of expecting. Let's see if we can't find this function in the source code. Is it? I'm going to do a grep. No, I don't want to kill that. Okay. Apache source. And I'm going to run a grep for this function. HTTP request.c located in modules HTTP request.c. I'm assuming the AP prefix that we're seeing in a lot of functions is just short for Apache. So give quick handlers a shot at servicing the request on the fast path by passing all of the. Okay, looks like this. We're starting to get to the good stuff. Process request internal. So actually, looks like this at first glance, what we are looking at, AP time process request. It looks like there's different functions for different methods of actually processing a request. This AP process async request seems to be just sort of like a wrapper for those various different methods. It just checks, hey, which method would I like best to process this request, and then fire off that subsequent method. Um, I'm gonna set breakpoints for the different ones and see which one it hits. I'm gonna copy this to a different tab. So there's AP time process requests. I'm just gonna save these over here. AP log. This is some sort of error handling. AP process request eternal. AP process request returned. So from what I found by just glancing over, it looks like these two functions are the two different real methods it has for processing a valid request. I say valid by the checks that I've seen. So let's set a breakpoint for this. And set a breakpoint for this. A breakpoint. Let's see, 2 or 3, or is my assumption wrong? My assumption was right. Okay, cool. So it hits AP time process request. I'm gonna continue and see what happens. AP process request internal. Okay, it appears that those functions were called multiple times. Could be because I'm not looking at the Wireshark and the exact HTTP stream. I'll be frank, right now I don't know exactly what that communication looks like. It could be that there's multiple requests flying back and forth. It could be that multiple of these function calls are made to service a single request. Right now, I don't know. But that was a bit interesting to see how multiple of those functions got called. I'm gonna try and trigger those breakpoints again. Okay, we got here AP time process requests. That was a bit interesting. We hit AP time process request before process async request. Oh well. Important thing. We know this function is called as part of the request processing code path. Let's see if we can't find where it is. Let's look for. No, that's not it. AP declare. No. It has to be somewhere in here. Not it, not it. Wait, is it? I wouldn't be surprised. Request.c. Wait, no. HTTP core. HTTP request I was looking for. So it isn't here. Where is it? Exports.c. constant void. Yeah. I'm going to take a quick break, BRB. So it's been 30 minutes so far, so I'm probably just going to end it off here for tonight. So in conclusion, what we did is we reversed out a bit of the code path that Apache uses to actually take a request in and scan it into memory. How we did that initially is we got a mixture of dynamic and static analysis. We first used a little bit of static analysis to effectively just like guess, like, hey, I think this function might be called. And then we set a breakpoint in the debugger and actually hit that function when Apache was scanning in a packet into memory. So we know, okay, hey, this function is called along the code path. And then we looked at the call stack and we effectively were like, okay, so we also know these other functions are called along memory. And then we leveraged that to look at the source code to see exactly, okay, cool, what other functions are being called. And yeah, I'm going to end it there. See you later.